Welcome everybody. Welcome to 11:15. We're going to welcome to the stage Rob Allen. This talk's on DDD, as you're probably well aware. Domain-driven design is a critical innovation to software engineering, and it will really strengthen your mindsets and how you approach building software from a conceptual point. And that's exactly what Rob's going to be talking and teaching you about today. So please welcome Rob to the stage.
Thank you. Thank you. I really, really like the way everyone applauds before I speak. It just really gives a boost to the confidence. I can't see anything from up here, so I will assume the room is packed, and I assume that you are all paying attention. But if you do fall asleep, do not snore, because I will hear you. Let's talk about domain-driven design. That's quite a term in itself. And it's all about a book. Domain-driven design by Eric Evans. This came out in mid-2003. A number of you were not in the industry when this came out. That's how old this book is. You can still buy it on Amazon, it is still published, it is still widely read. Not many tech books last that sort of length of time. I wrote a tech book in 2008, so 5 years after this one came out. You should never ever buy it. It is very out of date. Not surprising, tech moves forward, tech moves quite fast. But some things don't, and the way we architect our applications matters. And I think that the reason that domain-driven design and this particular book have stuck around so much is because of the subhead. Tackling complexity in the heart of software. For a complicated application, it is really difficult to just sit down, start typing, and end up with an application that is well maintainable. No, impossible. We have to do some thinking about it. We have to know what the software is all about. I mostly work in insurance industry adjacent clients. I'm self-employed, I do APIs mostly, and it's a lot of enterprise type work, particularly in insurance. Not quite sure how I fell into it, but I've been there for a while now. And it's really difficult to write insurance software that's actually usable for the people who need to use it if you don't understand anything about insurance. And the same thing is true for every other application, every other industry. Understanding the use cases, the areas of use that your software will be used in is important. And we call that the domain. Understanding the domain of the software matters for getting it right. I'm also very interested in this. I think it is important. I think that software is really complicated. I think it is difficult to write software because software itself is quite hard to write. There's a reason frameworks exist to try and help simplify it. And I think writing software in a business domain is equally complicated. So we have two complex things hitting against each other. And that's why this is such an interesting topic. Domain-driven design, or DDD, as you will see it called, provides for two different areas of focus, strategic and tactical. When we talk about strategic, we are talking big picture. The strategy behind the direction of our business, how the business is operating, how our software will solve problems that business has. I'm using the word business as a generic term to mean industry, to mean the problem space of the client or the customer or your users. Then we've got tactical design, the nitty-gritty, the details of how to actually organize your source code. We start talking about design patterns when we start talking about tactical. So we'll start with strategic. We need to understand the broader picture of how our software fits within the world. And we need to align it with the business requirements. And that alignment is really important because for your software to be usable, for your software to be long-lived and to be profitable for your business, It needs to be aligned with the problems that are being solved. Essentially, we need to find out what is part of the problem we need to deal with, what isn't, and we need to understand it. And that's where domains and models comes from. As humans, we think we have got really big brains. In practice, we don't. Our brains are really, really good at remembering things that we don't need to remember, and particularly poor at keeping a lot of information in scope at the same time. And we solve that in terms of trying to understand the world by creating models, creating simplifications of our environment that enable us to understand what's going on in the world. And that's where things like optical illusions come from, where your brain can get confused because you have already built a model of how you expect the world to believe, and what your eye is seeing doesn't match the way your brain already thinks about the world. And then we get an optical illusion. Building software doesn't need to include absolutely everything involved in the problem space. It's too big. We only need to worry about the stuff that we are actually writing the code to do, the problems we are trying to solve. And we call that the model, the domain model. Lots of jargon in this talk, sorry about that. Our expressions of this model can be code, can be diagrams, can be documentation. Doesn't really matter, but we've all got to be talking the same way. This is probably the most famous model in the world, the London Tube map. Absolutely my favourite model in the world as well. And I particularly like this slide because it's nice and white, so I can now see the audience. It's awesome. Right back in 1931, this was invented because we had a use case, we had a problem. And the problem was that our passengers on the tube needed to get somewhere else. They need to get from one station to another station without getting lost. And Harry Beck came up with the tube map, which is a model of the underground. You will notice that this particular model solves one particular use case that the London Underground system has. This would be terrible for the civil engineers, the people who actually have to care about where the stations are in geographic space. Because this model is all about helping you find your way around the system. It tells you which station is next, which station was before. It tells you where you can change lines. It gives you a very, very approximation of where you are in London, but it is not accurate about that, because that is not required in order for you to get from, say, North Ealing to Moorgate. It's all about modelling the part of the problem you care about. So domain is something in the real world. It's the subject of what our software is going to be doing, and it is the set of processes that are involving people trying to achieve a goal. That is our problem space, or our domain. It's not just a railway or an underground system, it's what is done by the people using that railway. Those are the processes, they are our domain. So that domain is the subject of our software. We call this a problem space. It's the bit we care about. We don't care about the rest of the company, the rest of the world. We just care about the bit we need to write software for. And the key thing about the domain is it is understood by other people other than you. It's understood by the experts in that space. I am not an insurance expert. I have got no idea how to go about underwriting an insurance policy. No clue how MTAs work in the specific senses. That's not my problem. I'm the software expert. My client, the people in the business, are their domain experts. They are the people who understand the problem that we are trying to solve with the software I'm writing. When you start talking to domain experts, in the same way as when you start talking to software experts, you very quickly understand that when you try to ask them a question, you will get back a different answer from every person. It's extremely difficult to get consistency of understanding between people. So, domain model. The domain model is a representation of the domain. It is not the domain itself. The point of the model, the reason we create a model, is to communicate the domain from those experts to the developers, the people who need to write the software. It's an abstraction of reality, as you could see from the tube map. We are taking the complexity of trying to write an insurance application and simplifying it down to something that we can understand and actually write software that will work for. We organize it, we divide it up, we make it comprehensible. One of the reasons why I like the tube map so much. Absolutely really clear why it's a good domain model. So it's expressed as diagrams, word, and code. Not a specific diagram, not a specific piece of source code, not a specific documentation, not a particular article or whatever. It's the idea behind them all that represents your domain model, the understanding itself. It could even be just a set of post-it notes that can communicate your model, because we are talking about communication here. This is where I tend to start when I think about domain models. Little simple pictures. Just write down some words, put a box around them, and draw lines between them. And you are now starting to model the problem space that you will need to write your software from. You start with the very broad concepts. A passenger, a ticket, we're taking a journey. Very, very broad concepts. You can't write software just knowing that a journey isn't going to exist. But unless you understand how a passenger needs a ticket to take a journey, you're going to struggle to write the software. So we start quite broad, and then we'll go more detailed. How do we build that domain knowledge? So we need to get that domain knowledge in order to create our model. How do we do that? Oscar Wilde. We really have everything in common with America nowadays, except, of course, language and possibly politics. Wilde definitely touched on a nerve when it comes to trying to communicate. Even though we have the same words, we don't necessarily mean the same thing by them. Where this happens in our world, in the software world, is that we will use phrases that our customers don't understand, that our business people don't understand. And they will use phrases that we don't understand. And the real problem is we think we understand them because we're software developers. We understand everything. We do the hard stuff. And you see that in my world with things like insurance. When they talk about an insurance policy, if I ask you, what's an insurance policy? You will be able to tell me what you think an insurance policy is, because you've got some experience of what insurance policies are all about. If you're really unfortunate, you've got some experience of having to do a claim against your insurance policy. When I talk to my client, who is a specialist insurance broker, their definition of the word policy does not match mine in the slightest. I'm writing software for their business. I have to use their definition of policy, not mine. And that happens all the time when you're trying to build software. So in DDD, we call this ubiquitous language. This is by far the most important part of this talk. Once I finish talking about ubiquitous language, you can go to sleep, and that's fine. This is the bit you need to understand. This is the bit that makes the biggest difference to the success of a software project over everything else. Turns out it's not the tech. Who'd have thought? Language is really, really hard. As I say, when we speak, we don't pick up the details very well. We need to talk a lot to ensure that we are not speaking at cross purposes. And ubiquitous language is the idea that we need to come to a common vocabulary. Technical terms, the agreed concepts and meanings and terms for this project. So when anyone on the team says a word related to this project, everyone else on the team understands what that means. And I know what you're thinking. You're thinking, that sounds really, really simple. Of course we are doing that. It's really not that simple. It turns out that we think we're doing it far more frequently than we actually are. We need this common vocabulary. It's limited to the domain problem itself. Do not try to work out a common language bigger than the actual software you're trying to build, because that's hard enough in and of itself. It describes how the business thinks and how the business operates. That is what we need to understand in order to write our software. And obviously, it means that we're on the same page. You have to talk. Software developers think that they can't talk. People go to software thinking that it is a lovely place to be an introvert in where you do not need to communicate. These people are wrong. If you want to be the best software developer you can be, if you want to be the top of the game, the staff engineer, the senior software developers, you are going to be really, really good at communicating, because that is the job of a software developer. It's a communications job. It's quite easy when you're a junior just to do the typing and do your tickets. By the time you're senior, you are talking a lot. Get good at it. I highly recommend it. There's nothing that will further your career more. We need to talk to our business people. We need to explore how the business operates. We need to identify the business processes that we need to understand to convert into software that will then solve the problem. We need to find the inputs and the outputs so we know what we need to take in and what we need to return back via reports, via displays, via whatever. And we need to write it down. Pictures, use cases, a glossary is really good, workflow diagrams, etc. It's foundational to implementing good software. It's foundation to good architecture. The cost of misunderstanding is very, very high. It's much cheaper to fix misunderstandings early in the process than late in the process. The absolutely worst case is when you get to QA and then you discover that you've misunderstood something. It takes a lot of rework to fix those sort of problems. Understanding earlier makes a lot of difference. How do we get there? We need to think about using the correct language everywhere. In our initial design, throughout our build, in our QA, in our launch, throughout the long-term maintenance of the project, we are going to use the correct language all the time when we are speaking about our project. This will be in our code base, it will be in our docs, it will be in our reports, it will be in our diagrams, it will be everywhere. And I appreciate that I am belaboring this point, because you all think you understand this. And then I get to see the projects later when I get hired in as a consultant and discover that the last time the glossary was touched was 4 years ago. And nobody's using those words anymore. And these people are using those words, those people are using different words, and the dev team is trying to build some software in the middle. It's difficult. Language will change over time, and we need to keep on top of that as we go. We need to update our documentation. We need to update our glossaries as we go. So that's ubiquitous language. It's very, very loosely just text written down in terms of understanding words. And I like it as a glossary. A project I was involved in a few years ago now We flew out to see the client out on the west coast of America, and we sat in a room with the project lead of the company, who was trying to explain to us the scope of what that company did in the context of the code we were taking on board. And what we did, we were listening, we were talking, and Gary, who's over there somewhere, started writing a glossary. Every time a new word came up that we had no idea what it meant, he put it into a little table and put a description about what that word meant. We ended up with a working vocabulary of that industry as far as the software that we were dealing with was concerned. Fine. We were in the room. We all understood the words now anyway. 6 weeks later, we got the source code. We're all back in the office. What does these words mean? We had the glossary to look back on. 2 years later, we've got new people onboarding onto the team. They weren't even in the meeting. They go to the glossary. That brings them up to speed on the terminology required to understand the software. I realize it's boring, but it's a really, really, really valuable document. When you're creating your domain model, this representation of the problem space, it's quite rare to get it right first time. This is one of those areas where you should be happy and pleased to chuck away a bad idea and go with a better one, which means that you do not want to spend too much effort too soon. As humans, we are particularly poor at throwing away something that we've spent a lot of effort on. We call it the sunk cost fallacy, but very, very loosely, the minute you start putting a lot of effort into getting something done, you become quite attached to it. And once you're attached to it, you are quite resistant to changing it, and you're quite resistant to throwing it away. When you're modeling your domain, use the lowest tech you can get away with in the most scrappy way possible, so that you're willing to change your mind. You will create a better model of your domain as a result. Don't try to model all of it, just model what you need, particularly at the beginning, because again, too much energy spent here will attach you too soon. Focus your effort where it matters. The bits of the business, the bits of the software that are unique to this particular piece of software. Do not try to reinvent the wheel when you don't need to. Do not try to invent new words for things that already exist. It's not worth it. This whole process of understanding and modeling a domain takes time. It's not quick. Don't do it for things that don't matter. So to actually build this domain knowledge, to actually build this communication, to actually get the information from the domain experts into our software team and make sure we're all on the same page, understand what we're actually building as a product. The DDD term for that is knowledge crunching, which I think is a particularly poor term. It's a bit rubbish, but that's what it is. The whole point of knowledge crunching is to distill the relevant information from the problem space into our model by collaboration with the business people. We're going to do this using whiteboards. We're going to be talking. We're going to be brainstorming. We're going to be prototyping. We don't need formal notation for this. I mean, you can use formal notation if it makes you happy, but you don't need it. It's a very, very fluid and dynamic process. The absolutely key thing is to get the right people in the room. You want the domain experts that actually have the knowledge you need about the problem. So if we go back to the tube map, for instance, you probably don't need the civil engineers to help you work out how to help passengers transit the tube. The civil engineers are probably not the best domain experts for that. The customer service people are probably better at it. You want the people who have to deal with the public trying to get around the underground to understand what the problems are. One of the most popular ways nowadays is something called event storming. This was invented by a guy called Alberto Brandolini, in 2012. So it's been around a while. It's proved to be quite successful, probably because it is interactive and simple. And those are really good features when you want to get knowledge out of a business person. It's just post-it notes on a wall. That's it. We get a load of people in the room and we put post-it notes on a wall. It's designed to be fun. It's efficient. It's very, very straightforward. Very, very high-level overview. We find all the domain events, all the things that happen in our software or in our problem that we are trying to write software for, and we write them down on the orange tickets. Anyone can do that who's in the room. Software developers, any of the domain people, the business people, the product owner, whoever's in the room, they're all capable of writing something onto a post-it note. There is no technological barrier here. It's quite democratizing. Once we've got the domain event for each one, we find out why that event happens, what process forces this event to happen, the command we call that. Those are blue in this diagram. We write down who's involved in that particular event, and that's the yellow at the top, the users involved. We might write down the business processes that happen behind the scenes, which are the purple ones, or the pink ones. And then we might write out what the users are seeing, which are those light green ones as well. And that's all there is to it. And what I really, really like about event storming, and you can get whole courses on this, what I like about it is that anyone in the room can pick up a post-it note and put it somewhere else. That level of dynamic changing as our understanding grows, and the fact that anyone can do it means that we are far more likely to get a better understanding of our problem. And once you've got it less, you take a photo, you can then turn it into a picture, it doesn't really matter. The actual getting people in a room to talk and explain the actual processes of taking a journey or renewing a policy or making a claim or whatever it might be is a valuable bit. People don't know what they know unless you tease it out of them. One of the better ways to tease it out of them is to stick a post-it note on the wall and say, this is what we understand so far. And they go, oh, yes, that's right. There's also this. And we put another post-it note on. And that triggers someone else. Oh, but you forgot about that business bit where we have to send the email out. Stick another post-it note on. Very fluid system. I like it a lot. Doesn't build you any software, though. You can't build software off a set of post-it notes and actually deliver something. You need to start diving deeper. Each event, look at the process from the user's point of view, and you get user story mapping. You've probably heard about user stories. They're fairly common in the world nowadays, particularly in Agile. The mapping bit is trying to organize them into a format that enables you to build the right bits of software at the right time. You need to understand the product's functionality, the relationship between the different bits of that product from the user's point of view. And this is an interactive example, but this happens more commonly using software by now. But I quite like the interactive version where you've got real people looking with real bits of paper, because again, I think that encourages people to change their mind and do things. In our remote world, of course, this is definitely going to be online. For user mapping, user story mapping, across the top, we write down all the user activities, all the main tasks or goals in our software product. Then, under each one, we write down all the steps required. These are the user stories. In this particular diagram, they're down here somewhere. Then we draw some blue lines. The blue lines are measurable outcomes, which is a jargon term for release. So what we're saying here is that this is one release, This is the next release. And this stuff doesn't matter because we never know what we're doing after 2 releases in the future. Don't bother planning more than 2 releases. No, it's a waste of time, isn't it? But now we can define exactly what is required for this software for the next release in terms of the user stories, the user interactions that matter in order to deliver working software. At this point, we're starting to get to the point where we can start building something. We can also look at it another way, and that's called event modeling. And what we're looking at here is how the information in our application will change over time. This is where we start diving even deeper into specific stories. And the key thing about this bit is we are thinking about time. What changes over time? In particular, state changes over time. Now, you're all software developers, so you probably already realize that state changes are one of the harder bits related to building reliable software. Keeping track of state changes is hard. So understanding where your state changes are is the first thing you need to understand in order to make good software. Just diagrams again. I tend to do this bit using software because it tends to be fairly slower paced at this point as we try to understand things. And we've got the same sort of concepts. So we have the concepts of a trigger. So we've got user, in this particular example, we've got user interface that does a trigger, which is a button is pressed. That button sends a command, and the command is add a to-do item. So this is a simple to-do list in this example. What happens next? We have to store some state. We have to change state, and that's down at the bottom in orange. We need to alter the state of the application. Whenever we change state in an application, we will probably end up changing the view. If you were in the keynote when Frick was talking about Livewire, exactly the same process is happening there. You change the state, you're going to have to change the view. It's a really, really common user interface pattern. So that's the green thing, an explanation of what happened to the view. Result of that change in the view will result in another trigger because the user is doing things with the software. Not all of the triggers are user-based. Sometimes they're cron-based, sometimes they're external, from webhooks or whatever. You just write them all down, but you understand their relationship to each other in terms of time. Some things happen before other things. It's useful to have written that down when you're designing your software. This is obviously quite detailed at this point. You're now probably at the dev team level entirely. So this is probably being done as part of sprints and things like that. And that was just a to-do list with one item on it, and I already had quite a lot of stuff on there. As you can imagine, this stuff gets quite complicated. As you start working out everything that your software actually does, over time, your domain model will lose integrity. Your understanding of the business problem as a concept will start diluting. The explicitness gets harder to keep track of as your software grows. Your software will grow. When was the last time you took out more functions than you added over a year? It never, ever happens. Software gets more complicated and busier and does more over time because we want to achieve more. As that happens, your language will become ambiguous, as different parts of the business are all now using your app. It is doing more stuff. And we solve this by dividing our model up. It seems fairly obvious. And the divisions are known as bounded contexts. Now, this technical term from DDD is one of my favorites because it says exactly what it does on the tin. You're taking your domain model and putting some of it into a box. You are bounding it by the context that you are thinking about. I think that's really, really valuable. So within the bounded context, This domain model is still defined explicitly. It's understood within that context. That means that we can have the language that is different in different contexts. Protects the domain model from dilution. So now, talk about that language thing. The classic example here is that we might have had a passenger when we were talking about our routing, but we might want to call it a customer when we are talking about them purchasing. Or we might want to call them a lead when we are talking about marketing to them. So we've got leads, we've got customers, we've got passengers. We can start using the correct word because within our application, we have bounded our domain appropriately. It can be quite powerful. If you don't pay attention to this and don't watch how your domain is diluting and your understanding of the model is diluting as your software gets bigger, you will end up with some software, and this is a technical term, it will become a big ball of mud. You will no longer have nicely explicit models because things and abstractions will leak between them. And then you have to fix it. And that is a horrible job. Absolutely horrible having to deal with software that has leaked into a ball of mud. Try not to let it happen. So bounded contexts are composed into an application. We have an application, it will have multiple bounded contexts. Each context is autonomous and authoritative within its space. It owns its own UI. It owns its own database connections or its own API calls. It is in control. So obviously, bounded contexts are great places to modularize or separate up an application, whether you do it within a monolith or whether you do it within separate services. We call them microservices, but don't split on arbitrary sizes. Split at bounded contexts, because that is where the authoritativeness comes from. We call them context maps, where we write down exactly what and how we have done this boxing up. These are my favorite type of maps because they're the ones I can draw very, very simply. They are very, very simple pictures, which are very, very loosely some circles with a list of the responsibilities for each context. And a few lines to remind ourselves how things are linked together. Most of us do not work on greenfield applications. It's very rare that you get to start a brand new application from scratch. That doesn't happen to most of us for most of our careers. So right at the far end over there, you will notice that I've got a box called Legacy. That's the rest of the application that has not been designed for this new feature that we have nicely understood and we've been building using our bounded contexts. Because in the real world, there will be bits of the application you don't understand. Nobody understands except for Joe, who left 2 years ago. That's the bit that nobody wants to touch. Draw a box around it and admit it to the world. That's the bit nobody wants to touch. So then we can actually do something about it in the future. If you don't acknowledge it, it's never going to happen. So yeah, bounded contexts, context maps. It's a way to ensure that you keep control of your design. And that's strategic design. It's all about understanding the business and turning that into a design model and into a design. We now need to actually build the software. This is tactical design. This is hands-on. This is code level. This is the design patterns that we use to build the software. DDD is technically agnostic. Implementation is flexible. It's open to innovation. That blue book is still 21 years old. We know more about software development now than we did in 2003. It is not a Bible, particularly when it comes to the details of writing the software today. It's got a lot of guidelines, common principles and patterns that are really, really useful. So let's look at some of them. These are the foundational ones. These are the ones that you probably already know or probably have already heard, at least at some level, and I highly recommend that you think about your software in these sorts of terms. Start with value objects. A value object is an object that is identified by its attributes and is immutable. Usually used to express some quantity or a measure or something like that. Good example is a £5 note. Back in the old days, we used to have notes for currency. Now we just use contactless. But any given £5 note is interchangeable with any other £5 note as far as purchasing something with it is concerned. It doesn't really matter which particular £5 note you have. That is a value object. Entities are identified by their identity. They are unique. They are not interchangeable. They are mutable. They will change state over their life cycle. And they are the most complicated bit of writing any software as a result. Generally, they contain rules and things like that as well. Users are a good example of a entity. You can't accidentally swap one user with another user without all sorts of GDPR implications. Aggregates is one of those terms that appears really complicated, but isn't. It is simply a cluster of related objects that you think about as a whole. So an example of that will be an online order, where you've got an order and you've got a number of line items that represent the items being purchased. So you've got an order object, multiple line objects, the whole thing we will call an aggregate. That's it. They're not particularly complicated. They're just a way of having a single word to represent multiple objects that are in play together. Typical example, here's my passenger. I've rather naively created it, and I can quite easily see that I've got an entity in there, which is the passenger's ID and its name and its address. But the address itself is a value object. The street, city, state, and zip code, because I was thinking American when I wrote this, is interchangeable. It doesn't really matter which particular value object or address object I have if it is on the same place in the world. So I can pull it out separately. And now I can reason about my passenger that much more easily. Storing state. There is an awful lot in DDD about storing state. Probably because it's quite difficult. There's definitely a mismatch between our nice set of related objects in memory, in our application, and that relational database set of tables that are on disk, and we need to sort of join the two together. Traditional DDD will deal with things like repositories. It will talk about mappers. It will talk about separating the storing of the state from your entity. And that's not a bad way to be thinking about it. Practically, it doesn't really matter as long as you understand how your objects are stored to the database or into whatever persistent storage you're using. My only advice about storing state is to do it the way that your framework does it. Don't try to bend your framework to do it the DDD way, because you are going for a world of hurt. In the Ruby world, there's a framework called Rails, which you've probably heard of. It's pretty famous. That's got a pattern for storage of state from entities, and they call that pattern active record, which you have probably heard of. That couples the storage of the state to the entity fairly tightly. If your framework does that, then that is the way you should do it. Don't try to beat your framework, because you may as well not use a framework in the first place. And it's likely that it works fairly well within the context of that code base anyway. I don't particularly care. I care more about services. Services are classes that hold processes, not things. They hold processes that are not specific to a particular entity or value object. If you can extract and identify the processes from your domain model into separate services in your code base, you will go a long way to having very maintainable software. So it's worth spending time thinking about the processes and how to code them as individual service classes, because they represent the business activities of your software. Think about that bit a lot. They're stateless, they're identityless, they're relatively easy to write as a result. The tricky bit is identifying them. Here's a service, journey router. It routes journeys. It takes entities, it does a process on them, it gives back a result. That's it. That is all a service does. Because we're human, we like to make it all more complicated, so we have domain services, which are the business processes. We have application services, which are related to the interface between the app and the domain. We have infrastructure services, which are things like login or sending emails. They're all processes. Just be aware that you're dealing with processes when you're dealing with services. And last thing you need to do is organize all that code into some sort of structure that you can understand what you did later. That's the hard bit, by the way. Understanding it later. It's easy to write your code in the first place. There's lots of different architectures. There's 3 to pick from the massive list that's available. DDD started with the layered architecture. Then over time, we came up with ports and adapters, which is known as the hexagonal architecture. More recently, we have things like CQRS, and there's other event-based ones as well. It doesn't really matter what you use. You should understand why you are using the one you are using and what its pros and cons are. So let's quickly look through these 3. So layered architecture. This one is really simple. I like it as a result because I can understand it. All we've done is segregated our app into separate layers. Each has a specific role. So the typical layers are the presentation layer, which is our user interface. It might be the browser, it might be an app, it might be a command line. Doesn't really matter. We have our application layer, which deals with the application-related stuff. We have a domain layer, which is our business processes and our business objects. And we have the infrastructure layer, our login, our emails, our stuff like that. Any layer at the top can call to a layer below it. Any layer below is not allowed to call up. So, very simple rule. We do not want our domain layer automatically being able to create a button on our interface. That's the user interface's problem. Similarly, if you look the other way, though, you get some interesting coupling, or bad coupling, if you like. There's nothing to stop the user interface executing anything from the infrastructure layer. Infrastructure layer's got really useful things in it, like login. It's good that I can log in my user interface. But there's also emails in there. It's not good if my Blade template is sending an email. That's probably not how you want to couple your application together. And there's nothing in the layered architecture to stop you, other than your own discipline. Which is probably why the ports and adapters architecture was invented, or hexagonal. I've got no idea why it's called the hexagonal interface architecture, other than in the original paper, they drew hexagons in all the pictures. It's the only thing I found. Ports and adapters. The idea here is that your domain model is in the middle, everything else is around the outside, and it cannot talk to each other unless it goes through the domain. So if we talk back to that coupling problem, we can't have our user interface send in an email because the email is the other side of the application domain. So you will need a service of some form, some sort of business process that means an email should happen. So you have now decoupled your user interface from the process of sending an email. That is good. Obviously, this is way more complicated to build than that layer architecture, way more harder to reason about as well. So you are bringing in additional complexity into your architecture for the benefit of reducing coupling and making mistakes. CQRS is something slightly different, but you hear it talked a lot about in terms of DDD, so we'll cover it. Command Query Responsibility Segregation, which kind of feels like they invented the words to fit the acronym. Don't know about you. But basically, the idea here is we are separated read operations from write operations, and we call the read ones queries and we call the write ones commands. And this is done because of scaling. In the average high-volume application, a lot more reads are happening than writes. So being able to segregate for scaling purposes starts to make sense. It enables you to reason about your application slightly differently, which can be quite helpful. You regularly see event sourcing used with this as well, but I'm not going to talk about that today. This is really, really, really good if you need to scale. It's incredibly complex as a result. And the main issue for me is that when you separate commands and queries up, you end up with either duplicate entities, duplicate models from your domain model have now been split into a read version and a write version, which you now need to maintain when you make a change, or you're going to end up coupling those domains with the database extremely tightly to minimize the amount of separation. Neither of which is necessarily ideal, but for the benefits of a flexible way to scale, those costs could certainly be worth it for the right application. It's definitely worth thinking about. And that's really what I want to talk about. It's all about the way you think. Don't just pick an architecture because that's what Rob said on stage, or that's what I read in the blue book, or that's what I read when I watched, or that's what was said in Greg Young's YouTube video. That's not the reason to pick an architecture. Pick the architecture that works for your team, for your problem. And that's it. Domain-driven design focuses on developing software from the business's point of view, and it models that business problem into a domain model so that we can understand it. The absolutely major thing I want you to take away from this talk is that strategic DDD is the important bit. The code bit, relatively speaking, doesn't matter for making great, working, maintainable software. Don't get hung up on those tactical design patterns and getting the code 100% right. Concentrate on your language with your business people and understanding what they mean and why those processes exist so that you can model them correctly and put them in your software. And that's it. So I'm going to leave you with this quote. Domain-driven design is about creating a shared understanding of the problem space. It's reinforced ubiquitously via conversations, code, and diagram. Nick Toon said that, and he nailed the really, really important bits about DDD. Thank you. All of a sudden, you found your mic.
Hello?
He's nearly found his mic.
Hello? Yep. On. Hi. Thanks, Rob. That was an amazing talk. Does anybody have any questions, any thoughts, any comments they want to share, perhaps?
Or you could go to lunch. I'm just saying.
He's sold it then. We've got a few minutes, anyway. Yep.
There's one over there somewhere.
I can't see when I'm on stage because of the lights.
The lights are amazing.
Would you recommend the Blue Book as a good place to start?
Would I recommend the Blue Book as a good place to start? Yes, if you're like me. which is not very helpful. I like reading RFCs, so yes, I think the Blue Book is a really, really good book. However, it is a very technical, very dense book to read. There's a better free book by InfoQ, I think it is, called Domain Driven Explained or Domain Driven Simplified. I will look it up, and I will put it up on Mastodon and into the Slack. That's a very, very good overview, which is not a bad place to start if you literally know nothing. And there's another book by a guy called Vaughan called Domain Driven Explained?
Implementing domain-driven design?
Yeah, that's it, yes. Implementing domain-driven design, that one. That's really, really good. The Red Book, they call that one, and that's recommended.
Who's next?
Hi. You mentioned during your speech a lot about domain, and I have a question. How do you actually persuade business to sit on the same table and discuss about domain?
How do you persuade the business to actually sit down with you and tell you what you need to know?
Yeah.
Yes, it's hard, isn't it? This is easier when you have a third party or if you have a good project manager. That's really what you need. Like, at the end of the day, the business, which is this horrible amorphous term, but there is a team within the company that wants some software written. Fundamentally, we are writing software because there is a reason for that software to exist. And as a software developer, we don't particularly care why that reason exists. We just want to write the software. So what that software does has to be defined by the team that wants the software built. A good project manager will want to deliver successful software. And ideally, they can communicate to that team that wants the software built that the way to get good software is if you actually tell people what you want. And that shouldn't be hard, but it's amazing how difficult that bit is. In general, I've not had a big problem with this. The things like event storming at the beginning is good for this because you really, really want to make it easy. And a meeting is a lot less scary than a design session. You will not get the business people to come to your 3-hour design workshop, but they will do a meeting. And you want a meeting where you are doing an informal chat, because then they will become engaged. And the minute they have become engaged and realized that you are listening to what they are saying, they will then start volunteering information, at which point you will write good software. But that's the knack. The knack is to make it simple or friendly enough that they will want to volunteer information because they believe you are listening to them.
Okay.
Which goes back to the whole thing that good software developers are good communicators.
Okay, thank you.
I hate people who put their heads up like this on stage, but I literally can't see you otherwise. Over there.
Thank you.
I suppose I could walk all the way to here, but then the camera can't see me, and they'll get upset.
So I have a question about domain dilution. And we had this example of the circles, how we talk about passengers, and each domain has its own terminology. So it seems to me that desirable that each team within their domain have their own terms. How do we actually approach this problem except maybe a glossary? So is there anything else that we can do, or is glossary the way to go?
So whether different parts of the team have separate words really depends on the people involved. And it's more of a side effect of reality rather than necessarily desirable. So you don't necessarily want the different bounded contexts using different words. It just tends to happen. The marketing team are so divorced from the civil engineering team, they may as well be in different companies. The terminology is just different. And if you don't accept that that difference exists, then it's very difficult to write coherent software. So the key thing in terms of that software itself is the absolute final definition is the source code. So the name of that class is the thing that really, really matters in terms of what you're going to call it. And ideally, when your new joiner comes on board and has to understand your code base, when they see an entity called passenger, finding out what that means in terms of the problem that the code is solving, why does this passenger exist on this website, how do you communicate that to a new joiner? That's the only thing we need to decide. And once we've got that, we can use it for everyone else. Glossary is by far the most obvious way to do that. Another obvious way to do it is a really good, reliable comment system at the top of every class, which you could then do automation to extract out of the classes and put into a published glossary on a static web page to allow the business people to read it. That would equally work. I don't really care where you write it down. I just want you to write it down somewhere that you can edit it and will remember to edit it when it needs to change. Does that help?
Yeah, thank you.
Great talk, Rob.
Cheers.
When you're talking about this, you've mentioned quite a bit, it's more of an enterprise context from your experience, it seems, which seems to suggest maybe it's not like these grand scale, lots of users or multi-tenancy and all of these sort of complex things of maybe a consumer-facing SaaS. Do you think that something like hexagonal or CQRS is appropriate for those setups?
Yes and no. It all depends. It all depends because I'm a software engineer. So therefore the answer is it depends. Practically, as a piece of application gets larger, different parts of it need to be thought about differently. And it's very dangerous to take one original idea and expand your software across multiple different domains or problem spaces as it grows and keep that one idea in place. I think that is problematic. In a large monolith, it's relatively hard to have multiple different architectural designs in play at the same time, unless you are very good at keeping separation between sections. I recommend doing that. If you can separate between sections, then it's easier to write a monolith than to split up. But you also need to deal with the real realities of the problem you're trying to solve. So if you have got a high volume section which is all read and maybe no writes or barely any writes in relation to the number of reads, then I'm definitely looking at CQRS for that bit of my application. Because I'd be silly not to, because my problem is I need to send out so many pieces of information really, really quickly, and my database is barely changing. So I'm going to be looking at caching systems, I'm going to be looking at CQRS to solve that particular problem. So I would tend to apply judiciously to the problems I've got.
Thank you. Do you have any tips on applying strategic design to existing software?
Slowly. It's really, really hard. And as I said earlier, we all work on software that already exists, which is by definition horrible because we didn't write it. As a general rule, we hate software that we didn't write. So it's all legacy, it's all rubbish, and we have now got to maintain it, and we all swear at it. That's what we do. But you're going to be adding new features to this software. You're going to be refactoring the software a little bit. You're not going to refactor the world because nobody wants to do a Netscape. Are you old enough to remember Netscape? Nobody wants to do that. You're going to take a small problem, you're going to have a new feature you need to build. For that new feature, you apply the ideas of ubiquitous language, the ideas of building your domain model to that feature only. So your very first context map is this tiny little feature, a little line, and a huge circle marked legacy rubbish. And you start there. And now you've got a little bit of your application where you've got a common language, you've got a better design within that section, or an intentional design, let's say. Then you go do another new feature, and you go build it off the knowledge you learned from your first little feature that you did with some DDD. And then you'll go build like that. You'll go refactor something because you've now got to fix something inside that big ball of rubbish. And you're going to take that little bit and move it to the boundary of the big ball of rubbish, or you're going to move it right outside because you've got enough time to refactor entirely into a better design. So you do it very, very slowly and very, very incrementally, because this is working software that's making money. And the last thing we want to do is break that, because we'll lose our jobs.
Yeah.
It is definitely lunchtime, by the way. What about you? There's another guy there.
Don't worry, like Sam said earlier, there's not, why go and queue up with everybody else? You can just show up when the queue's gone.
Hi. Is a translation a new word? Because we're a German company speaking German, writing code in English, so we don't have the same words in the code when we're talking about.
That's a good question, isn't it? I don't know the answer, whether it's a good idea or not to write your code, class names, or property names, etc., in your native language or in English. I literally have no idea which is better. Whichever works best for your team is my best advice.
Thank you.
No idea. So.
Yep, let's go.
Thank you. I have a question regarding documenting domain models and bounded context and so on for different teams. Like, do you do that in one big map, or do you have several small ones, or something in between?
I hate having to say it depends all the time, but it depends. Communication between different software developers, different software teams, and the business teams that they report to and work for, in my experience, is a problem for absolutely every company in the world. There's very, very few that have actually got a working system of communication. And if you happen to work for one, then use whatever system is working. Developers tend to react negatively, let's say, to things like Confluence or having to use the intranet system. Developers are not very good at doing that. They want to put it as markdown documents directly in their source code where they're in control and it's easy and nice. The average person in accounts is never ever going to read anything in your source code. So if you want to communicate anything with the average person in accounts, or the average person in purchasing, or the average person in marketing, or whoever your software is being written for, then clearly we need to get that information to them, and they need a way to get information to you to correct things and whatever. So personally, the companies that I found that do that well have a working system for a wiki-type documentation system. The one that's worked really, really well for one of my clients was a WordPress website where everyone had edit rights. And it was amazing how that company, across 4 or 5 different business teams, just edited in WordPress. And their entire documentation and a glossary system, they wrote it in a WordPress document, a WordPress website. That worked remarkably well for them. And practically, I don't care as long as people are using it. That's all I really, really care about. Their documentation is better than no documentation, but not by much. No documentation is the worst, no matter what anyone tells you. No comments is actually not a good sign of your code base. No documentation is terrible. Dead documentation is better than that. Living documentation is so valuable that it is worth instilling a company culture to update the documentation in the same way you update the tests, in the same way that you update the user documentation. You know, you don't ship software that doesn't have passing tests. Probably don't ship software that doesn't have passing tests. You probably don't ship software that doesn't have a help file. Now, if you write in a command line application, you add a new flag, you probably document it for your users. Get that culture into updating the internal documentation as well, and it will be so much easier to maintain that software going forward. I don't claim it's easy though. I'm not sure if that helped, but...
No, thank you.
So we should probably wrap it up there, bar one. So somebody put in Slack, his name's Gary.
Oh, him.
His
Okay.
question was, effectively, are there any kind of, you were talking about patterns like hexagonal ports and adapters, etc. His question was, are there any particular patterns or principles that you should avoid or approach with caution? Anything you've seen in your career that you should be like, hey, this is probably a bad idea or a bad example of how not to do, or a good example of how not to do stuff?
Not really. Like, thoughtful application of pretty much any architectural design is far better than not thinking about it. So my general thoughts on architecture in terms of organising your code base, organising the way the processes flow through your code, is think about it and decide it rather than just let it happen. So some design is always better than no design. Something like a layered architecture is so trivial that anyone can do that, and it's almost provided for free in most of the frameworks. Any of the full stack frameworks will tend to separate out the routing from where you put your entities and your models from where you put your view templates. You get a little bit of it almost for free, so a little bit of intentional thought makes a big difference. Things not to do, it's so much easier when you're a junior to have very strict lines of don't do this.